Okay. Think it might be working now. 3 years later. Okay, so yesterday, FYI, we added to our table of contents. I'm sure if you were absent, you probably saw this. We all added it yesterday, so do make sure your table of contents has this one. Remember, this foldable is all probability of one event. So remember, yesterday at the boards, we had 2 events happening sometimes. This foldable is just one event, and we're going to get a second foldable with more than one event. Okie dokie? So here's what we did yesterday. I'll quickly zip through. So if you were missing yesterday, write super fast. People who were here yesterday already have this. So stuff we did yesterday. We talked about what an event was. An event was what was favorable, what we wanted to happen. So event is the favorable. They use the word favorable a lot. Favorable. And it's basically what we want. Okay, so that's what we want. So if we talk about the event, that's the thing we're talking about getting. If you were absent yesterday, hurry up and fill this in because I'm going to be scrolling. The other thing we talked about was sample space. Sample space is going to be the total possible things that can happen. So your sample space is going to be your total. So when we did this first problem, it says you roll a number cube. That's a normal dice. If you roll a number cube once, what's the probability of rolling a 3? So we know on a number cube you can get a 1, a 2, a 3, a 4, a 5, or 6, right? So the total possible things that could happen are 1, 2, 3, 4, 5, 6 things. So we put the total possible is going to be 6 on the bottom. And the number favorable, how many of those were going to be a 3? Just 1. So it's going to be 1 favorable because this is the only one. So it's 1 out of 3. I'm sorry, 1 out of 6. My bad. 1 out of 6. 1 out of 6. And we talked about that we don't want to change it to a percent unless they say percentage, which most of the time they don't. And you also do not want to change it to a decimal that you have to round. Got it? So leave it as a fraction, and it does not have to be simplified. OST does not make you simplify, okay? The next one we only did the first 2 yesterday. So the next one was the probability of selecting a heart from a standard deck of cards. So we needed to know the sample space, which remember is the total. So what is the total number of cards in a deck? 52. And if you didn't know what a deck of cards looked like, you should go home and look at a deck and write it out so that you know for further questions. That way you got a visual in your head of what the deck looks like. So we need to know how many favorable things. So basically, how many hearts are in a deck of cards? 13 hearts. So there are 13 favorable things, cards that I would love to pick, and it would count. And the total possible was 52. So it'll be 13 over 52, which you can leave like that. You can simplify the fraction if you want. It does simplify to a nice pretty 1/4. But either answer is acceptable when you're taking a test. Okie dokie? What you don't want to do is have this right and then have you simplify it wrong. Because that would be sad, so sad, right? So make sure you simplify it right if you do choose to simplify. And your calculator will do that. Remember, you can do 13 ABC 52 equals, and it will simplify for you. Okay, so here's where we left off yesterday. Okay, so we're all back on the same page now. Okay, so just another vocabulary word, the complement of an event. The complement of an event is the event that it is not happening. So that's really all you need to know. The complement is going to be the probability of that not happening. And here's the symbol for it right here. You see this bar on the top? So this bar, you see the bar? Bless you. The bar means not. So we want the probability of that not happening, right? So the bar means not. So when you see it, it means You don't want A to be happening, whatever A happens to be. Okay? So let's do a not problem. So we have, what's the probability of not rolling a 3? Which means all we're doing is counting all of the other things, but just not 3, right? So how many things can we roll that are not 3? I could roll a 1. What else? A 2. What else? A 4. A 5. And a 6. So there are how many things that are not 3s? 5. So the probability of not rolling a 3 is 5 out of 6. Just look for this little symbol bar. That's really what you got to remember. Because sometimes they'll just put the bar on the OST, and if you're not paying attention, you might not see that there's a bar there. So look for the bar. If they put it on, they usually only put one question about it, but still that's an easy one to get right if you just notice that bar. Okay? And we see, what was the probability of rolling a 3? 1 out of 6. And you see how the probability of not rolling a 6 is 5 out of 6. So basically it's just subtracting from a whole, you know what I mean? So that's why they have that little notation there. Cool? Okay, let's go to the next column. So here's where they're going to use a bunch of fancy words. I highly recommend you ignore all the fancy words. Okay? I'm going to tell you the fancy words, but when you're talking about mutually exclusive events and non-mutually exclusive events and all of that stuff, you're just like, what are you even talking about? It's when it's better to just read the problem and use some common sense, because I think you guys have common sense if you don't worry your pretty little head over all the words. Okay? So, mutually exclusive events means there's no overlap. Now, some of the problems we did yesterday, there was sometimes an overlap when we didn't want to accidentally count something twice. That's an overlap, right? But sometimes things are separate, like the probability of picking a Twix or a Kit Kat, that's separate. There's no overlap, right? But if I said the probability of picking a heart in an ace, there was an overlap because there is that ace of hearts that you want to be careful not to count twice. And so that's what we're talking about with mutually exclusive events. Put that away somewhere. Okay, so let's go ahead and let's just use common sense reading this problem. So let's read it and underline key stuff. So it says you roll a number cube once. That's a dice, right? You roll it once. What is the probability of rolling an odd number? So let's underline odd number. Or, please emphasize and or because they matter. And that's where most of your mistakes happen, with the and ors. An odd number or a 2. An odd number or a 2. Okay, so let's stop and think. Find that word. Find the and the or so you make yourself pay attention to it. What does or mean? Do both things have to happen?
Yes.
If your mom says you need to wear pants or a shirt to school, you're allowed to wear pants, and you're good, or a shirt, and you're good, right? Right? Okay, so that means I'm happy if you're wearing your pants. I'm happy if you're wearing your shirt, but you don't have to be wearing both, right? If I say or. So or means one or the other, and I'm happy about it, okay? So when I'm talking about rolling this number cube, a number cube is super easy. Just make a little list. Make a baby list of 1, 2, 3, 4, 5, 6. I mean, it just takes you a second to make a little baby list. Now, you don't want to write a big list when you're talking about cards and all 52 of them. But for our number cubes, there's no reason. And why did I put my 6 so close to my 5? Weird. Anyways, they like each other. It's all good. Okay, so we want the probability of rolling an odd number. So of these, which ones would I be happy picking? I'd be happy about what? A 1. What else? A 3.
5.
And a 5. Okay, those are the ones I'd be happy about if I picked an odd number. Now, if I said or a 2, what would I be happy about? Just a 2. So I'd be happy if I picked any of those. Yeah? So how many is that? How many out of how many? So I'd be happy 4 times out of 6. So that's 4 out of 6. What does 4 out of 6 simplify to? Put 4 ABC 6 in your calculator. Double check, because if you're going to choose to simplify, make sure you're good. 2/3. Okay, now let's go back. Now they're saying you could actually break it up also. So let's do it their way and break it up. So if you want this or, if there is no overlap, if there's no overlap, which there wasn't, right? Because the odd numbers were all different than the 2. We didn't have to count anything twice. But you can just do odd. How many odd were there? 3. And how many 2s were there? 1. And possible was 6. So you could get it that way and get your 4/6 that way. Okay? If there's no overlap. Either way works, right? You get the same answer. So let's scroll a little because they put this in mathy notation. So let's look at this, because you're not going to freak out when you see that and be like, we never learned that, because you literally just did that. So let's think about what this says. Mutually exclusive events are when there is no overlap, okay, which just happened a minute ago. And you don't have to memorize that word. But you might see this formula here. But if you look at the formula, that's literally what you just did. So in this case, our A was what? Odd. And our B was a 2, right? So our A was our odd, and our B was 2. So all we did, if we wanted to find the probability of A or B, we can just find the A and find the B and add them together. So that's all that says, okay? So don't worry about if things look weird. When it looks like that, just say the probability of A or B happening equals the probability of A plus the probability of B, which is what you just did right here. A plus the B gives you the total. But we just used common sense and got it. Okay? Cool? Okay. Let's look at number 5. You roll a number cube once. There's your roll. What is the probability of rolling an odd number and a 2? So what are you going to underline? Odd number and a 2. So this is an and. Your mom says you have to wear pants and shirt to school. What does that mean? Both have to be happening at the exact same time, right? At the exact same time, both things. And. Okay, so and means both have to happen. So this is my number cube. I'm going to write it out because it's easy. 1, 2, 3, 4, 5, 6. Okay, that's my sample space. I can roll 1, 2, 3, 4, 5, 6. Okay, so I want it to be odd and a 2. So let's go through this list. Now, which ones are odd? 1, 3, and 5. Okay. I'm going to switch my colors. Which ones are 2? That one. Right? So are there any that are both? None of them have both check marks. If I said, is this odd and a 2? You would say no. Is this odd and a 2? No. Is that odd and a 2? No. Odd and a 2? Odd and a 2? Nope, nope, nope. So what is the probability of it being odd and a 2? 0. So 0 out of 6, which literally just equals 0. There is absolutely no chance of rolling a die and getting a number that's odd and 2. Your probability is allowed to be nothing. 0. Good? Tell me if you have questions. Okay, let's look at 6. Once again, lots of words here. Look at all these words. You guys have some space underneath it, don't you? You see how you got a bunch of space down there? I'm going to write over here because I don't want to try to scroll up and down. So I'm going to be writing to the right. I would put your stuff on underneath it. So let's see what we have here, because this is a lot of words and we don't want to have to look at too much. So it says you have a box of 100 balls. So you probably should do what with that? Underline it. Got 100 balls. You were told 30 are gray and 10 are red. So you're probably going to underline that, right? 30 gray, 10 red. Okay, that's what I've got. Okay, go underneath there and write down what you have so far. I'll write it over here. I have 100 balls, yeah? I've got 30 gray and 10 red. That's what I've got, yeah? So, what's missing? I got 60 other balls. Do I know what color they are? No. So let's just put 60. We don't know. There's some other color. We don't know. We know what color they are. We know they're not red and gray though. Just some other random color, yeah? Okay, so this is the information we have. And so sometimes they do that. They'll leave some of the pieces out. And what you don't stop and think about is the missing things they did not talk about, right? Okay, so now that we know what's in this little box, let's look at A. So let's just look at A right now. It says, what is the probability of choosing a gray or red ball if you take one without looking? So what should I underline? The or, for the love of God, yes. Gray or red. So this is an or problem, which means I'd be happy if it was gray. I'd be happy if it's red. Does it have to be red and gray at the same time? Is that even possible? No. Okay, so I'm happy with those gray ones. I'm happy with those red ones. So that means there is no overlap because you can't be gray and red at the same time. Where you can be an ace and a heart at the same time, right? Yeah? Okay, so there's no overlap because the balls can't be red and gray at the same time. So what would be the probability of being gray or red? So yeah, it's going to be 40 over 100, right? What's 40 over 100 simplified? 2 over 5? Now, since this one had no overlap, could I have used that formula? Could I have used this formula? P of A, in this case, A is going to be gray, right? So P of gray plus, oh wait, I should write it the other way. Let me write it over here. I'll just keep the A and the B. If we call this A and this B, is it true that P of A or B is equal to P of A plus P of B? Is that true in this case? Can I just get P of A? What was P of A? 30 over 100 plus what was P of B? 10 over 100. Could I have just done that? It works, right? Because there is no overlap. So you can just add them together and don't worry about the overlap. Okay, now let's look at the second part. Let's look at B. All right, B says, what is the probability of not choosing a gray ball? I want not choosing a gray ball and not choosing a red ball. So what does that mean? Let's use some common sense. If I'm not allowed to choose a gray ball and I'm not allowed to, if I'm not allowed to choose a gray ball and I'm not allowed to choose a red ball, what am I allowed to choose then? I'm allowed to choose these guys, right? Okay, so those are the only things that I can choose. So just stop and think what something means. If I can't choose this and I can't choose that, then obviously I gotta do the 60, right? Now, if you never wrote this down, you might not have even realized there were 60 extra balls in there that you didn't know about, right? So I can't choose red, I can't choose gray, so what's the probability? 60 out of 100, which is 3 over 5. So remember, when you read them with lots of words, literally just step back and think. Like, okay, well, if I can't choose that, then what do I have to do, right? If I had a deck of cards and I told you you are not allowed to pick any red card or any 4s. No red cards and no 4s. What does that mean I'm allowed to pick? All the black cards, but anything that's just not a 4. So basically I'm allowed to pick the black cards that are not 4s. And that's where I would count. So that would be, yeah, 24 over 52. Okay? Cool. All right, let's go to the last column. Is this the last column? Okay. So we have non-mutually exclusive events. See what I'm talking about words? That means if you have non-mutually exclusive, that means that you might have some overlaps that you don't want to count twice. Like right then when I talked about having the black cards in 4s, there is an overlap, right? Because there are 2 black 4s, so you don't count those things twice. So if it's non-mutually exclusive, that means that you're gonna have an overlap. So we gotta be careful with the overlap. And no, they're not gonna tell you, so that's why the words don't even matter. You just have to do the problem and figure out that there might be an overlap. Okay? So it says, if you roll a die once, so what are my options? What's my sample space? 1, 2, 3, 4, 5, 6. There are 6 items in my sample space. If I roll this once, what's the probability of rolling an even number, magic word, or a multiple of 3? What are multiples of 3? Counting by 3s. 3, 6, 9, 12, blah, blah, blah. Anything 3 goes into evenly. Anything divisible by 3, same thing, right? Let's break it up. Let's do it separate first. What's the probability of picking an even? Even would be this guy, this guy, this guy. So that would be 3 out of 6. Now, what is the probability of picking a multiple of 3? Which ones of these are multiples of 3? This guy is, and this guy is. So I have 2 out of 6. Now, is this going to work if I just add them and say 5 out of 6? Are 5 out of 6 of these good? How many are good? Is 1 good? No. Is 2 good? Yeah. Is 3 good? Yeah. Is 4 good? Yeah. Is 5 good? 6 good? Okay. So how many is that? So it's 4 out of 6. So I was not allowed to just add these and get 5 out of 6 because I have an overlap where at? The 6 is an overlap, and I want to make sure I don't count him twice. So all the time when you do these problems, double check and make sure you're not counting anybody twice. Same thing when we do probability in a two-way table. You want to make sure that you don't count people twice. All right, cool. Yeah? Okay, so look at this formula. Here's the formula for non-mutually exclusive events. And that formula shows up on your OST formula sheet. I think flip to the back of your book, the second last page. I think it's right by the pink page. There should be 2 white pages by the pink page. No sleeping time. It is, yeah, it's at the bottom of one of the pages. Do you see the mess of the formula? Is that the same formula or no? Oh, that's a different one? Did they give you this one or no? Minus P. Oh, it's the same one. Yeah? It's the same one? Okay, so they do give this on there, and people will be like, what is that even talking about? And there are some types of problems where it's easy to use the formula and just plug in. But when you did a problem like this, here's exactly what you just did. So let's think about this problem you just did. Because you did that formula just now. You just didn't know it. So what we did was we found the probability of both of them separate, and then we basically subtracted off 1 because there was an overlap, right? That's all this formula is saying you're going to do. So you're going to find the probability of the first event, right? Plus the probability of the second event. So that would be like the 3 plus the 2, right? And that gives us 5. But we knew 5 was not good because we had to subtract. See how it's minus? We had to minus what they had in common. So what they had in common was that 6 on the end. And that's why we had the 2 plus the 3 gave us 5. But we had to subtract 1 off of it. And that's how we got 4 out of 6. So we actually did this formula without actually doing that formula. Okay? But sometimes they may throw in a problem, and what happens at OST times, people are like, we never saw that before in our life. We saw it, we just used common sense instead, right? Okay? Good? Okay, so let's go ahead and try number 8. Number 8, you select one card from a standard deck. Now, I'm not going to write out all the cards. You choose one card from a standard deck. What is the probability that it is a club or an ace? What do you want me to underline? Club or ace. So this is an or problem, which means I'm happy if it's a club, I'm happy if it's an ace. Okay, so let's talk about what the probability of, first thing, is there an overlap between clubs and aces? If I counted all the clubs and then counted all the aces, is there anything that's both a club and an ace at the exact same time? Yeah, we do. There is an ace of clubs in that deck, right? So we can't count him in the clubs and then count him in the aces. That makes no sense. So there is, it is basically the ace of clubs is an overlap. And there's only one ace of clubs. If you look, he's right here. Ace of clubs. There is no other ace of clubs in the deck. That's it. Just one. So the probability of clubs, if I just found the probability of clubs, what would I say? How many clubs are in that deck? 13. Because there is ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. That's 13 out of 52. Okay, what's the probability of ace? Is just 4 out of 52, right? There are 4 aces. Ace of hearts, ace of jack, ace of spades, and ace of diamonds. So if I want to use this formula, I would add these together. So let's go ahead and use this formula right here. This formula says I take P of A plus P of B. So I would take 13 over 52 plus 4 over 52, right? That's what this formula says. P of A, first event, P of B, second event, minus the overlap, which is when is it P of A and B? So that only happens how many times? Once, that ace of club. So that's going to be a 1 over 52, which is you using the formula. Nobody says you have to use the formula, though. You can use common sense, but I want to show you both ways. Sometimes they'll give you decimals for some of these events, and it's going to be easier just to plug them in and solve for a missing number if you need to. And I'll show you some when we practice that look like that. We'll do a couple right before OST because they like to magically throw one of those on there. And it's easy if you just know how to plug in. So 13 plus 4 minus 1, how many things do we have? 16. So the probability of club or ace is 16 over 52. Does that simplify? It does. Put 16 over 52. 4 over 13. What? 4 over 13? Okay. This right here is a typo. This is supposed to be and. So change the second one to and. One of them's supposed to say and one's supposed to say or. Obviously, I wouldn't do the same thing twice. That's weird. Okay, so what if it was an and? How many cards are clubs and aces? Clubs and. That means it's got to be both happening at the same time. One, and I just showed you. Rachel has it. There's only one ace of clubs out of all of them. So this is going to be 1 out of 52. So you got to find a way to remember the difference between and or so that you make sure you don't miss that word. I would find that word and circle it no matter what, so that way you know, because obviously you're getting a different answer. Way different answer, right? Okay, so this is being glued. We are gluing that on page 56, where you put in your table of contents yesterday. So you're going to glue, and I'm going to give you the practice paper, which literally takes you probably 10 minutes. So if you're fast, you might be able to do the practice paper right now in class. Put your cards at the end of your table. I'll grab those. This only has 9 questions, and it's basically stuff we just did. So should be all good.